Howdy, folks. Same old me again. The question got reset that still we're solving the issue problem. So, yeah. So, the today Leetcode problem is we have to check the power grid maintenance. I think this is also look like a heap question. Yup, and pretty cool. And then one good thing is this is not the hard question. So we are given an integer c representing the c power station each with a unit number of id from 1 to c. That means like this is a one index space indexing. So each station are connected bidirectionally cable. That means like 1 and 2 is connected both bidirectional cable representing the two-dimensional array, which is a we call it connection in here. And then where each element connection of I, where the U to V indicate the connection between the two stations, like the first station to the second station. The station that are directly or indirectly connected from the power grid. So initially, what we can expect is all the stations are up and running. That means all the power stations are operational. And we are also given a two-dimensional array for the queries, where each query is one of the following two types. That means like if the query first index, mean like 0 index, is start with the ones, we just want to check the request from the station X. We want to check the station X is up and running or not. So if the station X is offline, we have to resolve the operation station with the smaller IDs in the same power grid as the X. So if no operational station exists at the grid and return the -1. The 2 is the station X go offline. That is like become the non-operational. Okay, maybe I will take this as a screenshot and explain. Okay, luckily I have not cleared the heap XML in here. Okay, let's use this as XML, and then I will also need the XML2 for the demonstration. So crazy, guys. It's around the 1:20 AM in my side and around 2K people are online in Leetcode. Alright, so let's go through it. In here, what we can expect is we have input is 5. That means we have a 5 power station. This is a 4 connection. That is pretty straightforward because we have a 5 station and these okay, one thing we cannot expect, there should not be the only one direction. There could be the chance like 1 in here, 2 in here, 3 in here, and then they could also be interconnected like this. So this is just an easy peasy XML to demonstrate for us. So when going through this, we have a connection 1 to 2, 2 to 3, 3 to 4, 4 to 5. That is also pretty straightforward. They just want to describe like all these stations are interconnected each other. Then there's a queries came in. So when the queries came in, so we have 1, 3. We're going to check the station 3 is up and running. Yes, that is up and running. Then we return the 3 in here. The next is a 2. 2 means like we want to shut it down, the station 1. So this one's down. And then next is we want to check the station 1. So since the station 1 is down, where we can search with the nearest station with the lower station ID, which is the station 2. That's why the 2 is in here. And the next is we shut down the station 2. There, the station 2 is down. And the next step is we're going to check the status of the station 2. Since the station 2 is down, we can only check for station 3. There's a 3 came in front. So that's why the answer is a 323. So let's look at the XML2. For the XML2, what we can do is we have 3 stations, but they are not connected to each other. Okay, let's say it's like 3 connection is like this. Okay. And then they are not connected to each other. We want to check the query like one is up and running or not. Yes, since we are checking the one for one, we just return the one in here. Next, we want to shut it down the one. So we shut it down this. And then we want to check the state of the station 1. Since the station 1 is not connected with any of the station, so we just return the -1. I hope you guys understand the problem. Then we can start code for it. So to create that, the best case I can think of is this. If one is cam to the two-dimensional with the both bidirectional interconnected nodes, it's best idea to use the adjacent lists. Still, we still need to use a heap from the yesterday. So to save the time, I won't recreate the heap and I will just copy paste from the yesterday. Okay, let's just paste my previous code from yesterday, which is exactly the same as how we create the heap. And then if you guys have a code base, you can always check out in the yesterday video. Maybe I will put in the description for the gist, so you guys can go there and copy it. Alright, so after we create that, we can also create the one thing for the extension of our heap, because we don't want to use okay, in here, every time we create the heap, we need to parse the heap we are using is a minimum heap or maximum heap. So we only want to use the minimum heap in our case. What we can do in here is we just normally, if I don't create the extension, let's say if I want to create the one heap, let's go like heaps, and then okay, I have a heap in here. I need to define the type is integer. I need to pass like it is whether it is a minimum heap will be like this. If I don't want to do like this, I can just use the minimum heap. Okay, let's go with this. I don't want to create an extension in today. So what we want to do is we just want to create the adjacent list. Let's call it adjacency list. I will be using the array repeating of the. Oh wait, what is wrong? Let me scroll up a little bit. Okay, that's much better to read. Right, am I logged in? Correct. Repeating will be the integers array also, since we are creating the array like this. So if I'm here creating adjacency list is pretty straightforward. So maybe I will demonstrate about how adjacency lists work. Let's say for the adjacency lists, I need to define my adjacency list count. Let's say if we have 5 idents, pretty sure that will be the around 6 in the list. Why like that? What we can create is we want to create the adjacency of the head. Let's convert this to black color. So 1 is a key in here. So what we want to append is we have a connection like 1 is connected to 2 in here. It's just array, and then 2 is connected to 3. After that, 3 is connected to 4. So at the same time, if we add like 1 is connected to 2, but same time 2 is connected to 1. If you check from here, I will use the green color in here. So 1 to 2 is 2 to 1 is like that. And then for the next step, 2 is connected to the 3. That means 3 is also connected to the 2. We done for the second connection. So the third connection, 3 is connected to 4. Same time, 4 is connected to 3. And then next is 5. 5 is connected to 4. So it is, we're expecting like this. 1, 2, 2 to 3, 3 to 4, 4 to 3, and then 4 to 5. that would be the 4 to 5 would be like this. I was thinking the best idea to explain how is the best approach. So yeah, so this is what we are expecting since we have a connection of the phi, not a connection, let's say it's a element of the phi, and then yeah, and then we can also connect like 0. Okay, that is the reason we need to create the adjacency list. Okay, let's create for it a repeating array, and then count will be the c plus 1. So let's call it like a element, and then in connection, so it is just going through the connection, and then what I'm going to do is I'm gonna create the tuple. Let's call like u and v, so which is a very easy here, do connection. After that, what I'm going to do is this should be the station, much better, station of 0 index and station of 1 index. So what I'm going to do is adjacent of the u is I will just append the v. Vice versa, adjacent of v will be append the u. So I can demonstrate the some data structure to you guys first. Let's go like just bring out the adjacent in here and here. Let's just run it out and see what will be our data for the expected. So as we expected, we are expecting the array like this. That's the reason why we are creating the array, two-dimensional array to the 6 item. Why? They could be the like we need to consider for the empty array, and then we also need to connect like 2, 1, 3, and then 2, 4, 3, 5, and 4. After we have connected each other, what we need to do next step is we have to create the we will use a one data set to keep track of the station is online or not. In here, if we use a 2, that is going to be the station where it goes offline. So for that case, I think it's pretty straightforward. We can just use the set data set. Also, it is mentioned that our connection or like station ID will be unique in here. So that's the reason we can use the set in here. If not, we have to use the array. So let's go set. And then next is we will use a heap in here. So for the heap, I'm going to use a dictionary in heap style so that we can reuse if we want. Okay, I think this is very ugly to read. Let me create the extension. For the extension, I'm going to create for the extension for heap where the type is comparable, since we need to make sure that our data type using heap should be the comparable, so that we can just create the minimum heap. Let's call minimum heap, and then that's going to return the heap with the type, and then it should be the heap of less than. So we don't need that in here. So our heap is now will be clear like this, and we can initialize the array. So what we need to do, we just need to iterate through. Let's go like start in 1 through 6. The reason why we start from 1 is if I print out the adjacency list in here, so there's no chance for us or no reason for us to use this empty array. That is the reason why we start from the 1. And then what we are going to do is maybe we can only check like yeah, we need the one more data structure in here, which is let's go like component ID. That will be the array, same as the previous one. We're going to use the integer array with the count of c plus 1. That's better to use a comp ID. So in here, what I want to do is I want to check the comp ID of start, I mean like start from the index 1, is everything is equal to 0 only. That means we will only iterate through the array where the component ID is only one time. That means if we have been to destination, we will never come back to destination and check again. So what we're going to do, let's create like component ID, because we are going to call the station here. Let's call it start, and then we will use the stack data stack. Okay, let's call it start is in here, and then what I'm going to do is I will use that start ID to put as a component ID. That means like if it is a 0, I will put initial as a 0 for the dictionary. So that means if index of 0 will be the 0. Wait. So since the start is 1, what we are putting is we are putting the 1 in array, and then we are putting the comp ID of start index, which is a 0 index. Let's call it this is star, and this will be the 1. That is what I'm doing. So the reason to do like that is because we want to use a heap. So we are just preparing the heap data set for approach, and then we are using the minimum heap, or we can just use like this. Okay, let's use like this at the moment. And then let's do the while loop. We will pop it up all through from the stack, and there is nothing left in the pop. Let's call like what you need, and then from the stack we're gonna pop it out. Pop mean like we will pop from the left like a potato stack or potato box. And then after we pop less, what I'm going to do is I'm going to put the stack item from the stack to put back in the heap. So we have a heap in here, the put back, and then I will also insert the online, because that means that if we insert the bag, that means our station is up and running. So insert you in here. And then next is we need to go through our adjacent list. Okay, let's make it more readable. So let's go like V. Since we are going to index the second connection in here, that's why we're using the variable V, not to be confused, in the adjacent of U. And then we can do like component ID of V is to the created component ID in here, which is the start in here. The reason to use the V is we're going through all the dictionary in here. If I would say we have this kind of data set in our adjacency list, not here, here. So in that adjacency list, we will be what to do next? we are only indexing through our v, which is a second connection. That means like these are all the second connection in here, like 2, 1, 3. So if we index like this, we can just append that data to our stack for the v. After that, we then for the heap, and we just put the heap as a CID, which will be the start. So we are using the original value, which is a root for the heap, as a keys in our heap. So if I have to print out the heap value in here, so that will be the, let's call like heaps of, okay, just print the heap for you guys. And I will run it out. It will show like a dictionary of key ones with the 5 item, 1 to 5. That is what we are expecting in the heap. If not, we do something wrong. Right, something wrong. So that's causing the memory limit AZ. The reason why, even though I'm popping the last item, and the even, oh, okay, I need to check one condition here. So we will only check where the ID of the fast, the second station, is not visited yet. So we don't want to visit many times. So that will save the time for us. I think I made something wrong here. For v in JSON of u, what did I do wrong? I should use the comp ID in here. Okay. All right, that is what I'm explaining. I'm trying to use. So that is our standard output. So we have a heap with a key, which is a root 1, and then this is the element. So that means we are creating the heap like this. Let me create the heap for you guys. Empty background. Let's call it a 1. Okay, is it too small? Okay, maybe a little bit small in here. Okay, what we got is a 1. Let's do 1, 2, 3, 4, 5. So by knowing that dictionary key is a 1, we know that our root is a 1. And then we have 2, 3 in here. 2, 3. So which will help us to create the minimum heap. 2, 3, and the 4, 5 will be in here and here. There. So that is what we are creating. But the good thing is, after we have created the heap, we can traverse the heap during we solving the problem. So this is only preparing the data set. We convert the one directional into the heap data structure. And then what we want to do is we are going to create the answer array, which is going to be our final answer. And then let's go through for the query in, since we are already prepared the data, let's call like type, since we will know like the query of 0 index. If it is 1, mean like 1 check, and then 2 is shut down offline. So it's pretty straightforward for us. And then we also need to know the station, which is a query of 1. That's also clear. So this is in 0 index 1. After that, what we want to do is we want to get the our component ID in here. Let's call it CID, and then ID of station. So what actually is a component ID here, I can demonstrate for you guys. Let's run it through and see what is in our component ID list. So just that. So what I mean is we just simply create the 5 item, and then the index 0, which we won't be using, and that is the why every station is up and running. That's what for the component ID. So if it is go offline, we're going to make it 0. That means it's offline. So we got what we need, and then we will check like if type is do, we need to shut it down. How to shut it down? We just use the online.remove, since online is a set data structure, and then we just remove our station. So that means I will pop it up from our set, and then if we want to check. So for the check, we need to do then. So to check, we have to make sure the station we want to check is online or not. So it's really straightforward since we're using the set data structure, and then we can check like if the station is online. What do? We just append that station ID to our array of answer. If the station is offline, that is here where the real measures come in. So we need to use a heap. So we have a heaps already prepared in here. So we are going to accept from the heap of the CID. CID in here means always provide the station. So station mean like mostly okay. I will create the code and I will show you the demonstration for you guys later. So we are okay. Let's use a false unwrap, which is not a good option, but let's do it in here. And then we're going to need the sneak peek. Let's call like top, which is a root of our heap. So we will check like top peak. So we will check if it is AZ. What do? We will also check if it is online or not. So the reason why we need to check is there could be the chance if it is not even containing the station yet, and then if it is online, it's just for default confirmation. Let's call it online of contains dot d. If it is contained true, mean this online. If false, then we will make it reverse. And then what do? We cannot do like pop it up the item from our heap. Pop. Wait, this is execution. Let's do it like this. After that, we have done for the heap. And then what we need to do is we need to update our heaps of CID, which is in here, component ID, and then just update our heap with the H. And then we will append the answer by picking our root of this heap data structure, and then if not, we just put the default as a -1, and then we return the answer in here. So to explain what is the CID really doing in here is I can just print it out. CID would be the CID in here for what do we need for the query. So I will run through and make a dry run for you guys. So now, should be the top. Actually, I need this condition. We can pop it out. Never mind. Let's try first. Okay, here we go. So our CID always will be the 1. Why? Since every time we ask for the station, so we are checking from this component ID. Component ID is everything is a 1 at the initial stage. So we have a query like a 1 3. Not sure why the 1 3 came in first. It should be the 1 2. Okay. Wait, I'm seeing a different or what? Okay, 1 3. Okay, correct. This is a query 1 3 2 1 1 1 2 2 1 2. So in here, after we check it through, every time we are receiving a CID is a 1. That means even though if we want to update the heap in here, since heap root is also the one only. This is for the dry lamp. I think I can remove that. Let me see if it's work or not. Oh yeah, we need to check that, because there will be the chance like online is still containing the root of the heap here. Let's try. I forgot to remove this one. Wait, one cam is like 2000 millisecond. Maybe because of the print. Let me try again. Yes, it's walk, and let's check the. Okay, I think it will be O of, and it will be O of K log K if I'm not wrong. For the space complexity, that will be the O of C. That means O of N. Yeah, that's all for today. I hope you guys enjoyed it, and I will upload the solution in Gears for you guys to reference. See you guys in the next video.